Hello year twos, let's just jump straight into the math, shall we? This is one of the days right here. I'm going to go over question number 2, this question here, question number 5, and the extension as well. Alright, I'm not going to worry about the arithmetic. I think that you've got skills to try and sort it out yourselves, and you can look at the past videos as well to see the different methods. Alright, let's go on to question number 2. Let's do this. Alright, question 2. Robert Falcon Scott packed 60 snacks. I'm gonna get this 60 here because I do like that number 60. I think it's going to be important. 60 snack bars for his trip. He shared half with his team and kept the other half. How many did he have? So the word half here tells me that it's going to be a division. And also the word half could look like this as well, half. Alright, so we've got 60 and we've got to half it. That's basically what we're doing. So here's our 60 and then we have got to half it. That means you've got to share it between 2 equal parts. So this 60 right here, we're going to share it between these 2 equal parts. We're going to find out how much he's given away, how much has he got left. Right, so 60. Now we take forever to count out the 6 ones, so let's break it up and let's count in tens. So there's 10, 20, 30, 40, 50, 60, and I'm going to put them in, share them out. 10, 20, 30, 40, 50, 60. Drawed my deans in here. We've got 3 tens there. We know that 3 tens is 30. Another 3 tens here. We do have equal parts, people. So half of 60 is 30. How many did he have left? He has 30 left. Bam, done it. Here's question number 5. At the end of his expedition, Christopher Columbus had 5 full laundry bags. Now each bag had 6 jumpers in it. How many jumpers did he have that needed to be washed? So you can draw a little pictorial representation here. 5 full laundry bags. Each bag has 6 jumpers in it. So, love my bar model. So this bar is going to represent a full laundry bag. So we know that he's got 5 full laundry bags. So here we go. 1 laundry bag. 2, try to make them even, Mr. Guevara. Try to make them the same. Oops, that's a bit too big, but let's just know that they're the same. It should be 3, 4. 1, 2, 3, 4. Yep. And the 5th one is here. 5 full laundry bags. Fantastic. Now each bag had 6 jumpers in it. 6 jumpers in here, 6 jumpers in here, 6 jumpers in here, 6 jumpers in here, and 6 jumpers in there. So this is what it looks like. You could even say that you had 5 lots of 6 equals. Now, you know what? I find it difficult to count in 6s. Don't know about you. I think it's pretty tough. So I need to go away and practice that. But what I do know is that multiplication is commutative. So 5 multiplied by 6 is also the same as 6 multiplied by 5. And I do know how to count in 5s. You could use this method and draw all your dots and count them all. Or you can count in 5s 6 times. Even though it's not what it's asking here, it will still give you the same answer. So 6 lots of 5s. Once you've worked it out, you probably know that it comes to 30. And just to prove it, 5, 10, 15, 20, 25, 30. 30. I hope I've proved that to you. Well done if you've done that. Multiplication. Question 5 done. Let's move on to extension. Okay then. Here we go. I start my journey. Here's my journey. Woohoo! Lovely line there. Start my journey at 12 o'clock. So here's my 12 o'clock. Okay, and it finishes 2.5 hours later. So 2 hours and a half. So this is 1 hour. 1 hour. I did HR for hour. I've just been lazy. I should have done HOUR, but oh well. And this is a half an hour. Alright, so what is my time after 1 hour at 12 o'clock? then after that, and then half an hour after that. Got my timeline there, but I've also got this little clock here. Okay, so let's see. This is the minute hand. It has to go around all the way round to the top again, so that we know that's 1 whole hour. So this is 12 o'clock because the minute hand and this hour hand here is pointing to the 12. Okay, 12 o'clock, all the way around. Oops, going backwards here. Here we go, all the way around once. That's 1 hour. So now it's 1 o'clock. So here is going to be 1 o'clock. It's getting all bunched together here. Looks a bit dodgy. That looks like 10 o'clock, but it's actually 1 o'clock. And here we go again. Another hour passes by. And oh look, it's a 2 o'clock. So here we've got the 2 o'clock. Okay, let's write that down here. 2 o'clock. Right, and then here we need to go halfway around. Say stop when I've gone halfway around. Brilliant, I heard you say stop with my fantastic ears, and that is the time. Okay, it's gone halfway around. It's gone half past that hour. Work it out. I'm not going to write it down for you. Let's move on to the next day. Okay, well done everyone. Here we go. Okay, so here are the next sets of questions. Not going to do the arithmetic. Let's just go straight to the word problems. I'm going to be looking at question 3, question 4, and also question number 6 here. Alright, the rest I feel like you can do it yourself. Draw your bar models, help you out. Question number 3, let's get on this. Question number 3 says, an explorer walked over the Great Wall of China. Every 10 minutes, she stops. How many times does she stop in 50 minutes? Okay, let me draw a little picture for you so that you can get a good idea of what it is. So every 10 minutes, she stops. So this is her walking and stopping 10 minutes. I'll put 10 min here. So that's 1. Now let's go to another 10 minutes here. She stops and walks another 10 minutes. Now we've got to do this all the way until there is 50 minutes. We want to know how many times she does it, or does she stop until it's 50 minutes. So you probably can see there's 10, 20, 30, 40, it's another 10 minutes here, and 50. Look at me getting lazy towards the end, not even finishing in minutes. 10, min, mins, min. Anyway, how many times does she stop in 50 minutes? 1, 2, 3, 4. There are 5 times that she has to stop in 50 minutes. Okay, let's move on to question number 4. And it says here, on a crowded train, there were 60 people. 1/4. Alright, so I'm going to write down number 60 here. I think we're going to find that very important. And 1/4. So this is what a quarter looks like. Right, the denominator tells us how many equal parts there are. The numerator tells us how many of those parts we're actually looking at. Okay, so 4 parts of the whole, and 1 of those parts is what we're looking at. So 1/4 leave the carriage and wait at the platform. So how many people get off? So that's how many people actually get off the carriage. They leave the carriage. So we want to know what that quarter is. So we want to find out what is a quarter of 60. Okay, here we go. 4 equal parts, right? So we've got 60. Got to divide it into 4 equal parts. I see 4 equal parts here. 1, 2, 3, and 4 equal parts. And it's going to take forever to count these out in ones, so let's do our 10, shall we? 10, 20, 30, 40, If I do 50 and 60, it's not going to be even, is it? Okay, so I've got 40, which means I've got 50, 60 left. So I've got a 10 and a 10. I've got to split this 10 between these two, and I've got to split this 10 between these two. All right, I'm very clever. I know that if I split if I split 10 in two parts, I've got 1, 2, 3, 4, 5 here, 1, 2, 3, 4, 5 there. Just to prove it to you, watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see that? Yeah. Alright, we've got a 15 here. 10 and 5 is 15, 10 and 5, 15, 10 and 5, 15. I've checked to see that they are all correct. So, this is the amount of people that have got off the train. 15 of them. So, how many people get off the train? 15 people have got off the train. Now the extension is how many people are still on the carriage. You know what? That's all of this, isn't it? If this lot got off the train, this is how many is left. I'll leave you to try and figure it out and work it out. Okay? Well done. We'll move on to the final question. Number 6. On his bike, a man rides for 3 minutes. Ooh, it's another time one, isn't it? And he does this 6 times. So how many minutes does he ride in total? So here's the man riding for 3 minutes. This is going to represent him riding for 3 minutes. 3, I'm going to be lazy again. I'll put mins. Honestly, Mr. Guevara, 3 mins. So after 3 minutes, he's done it once. Okay, he says he does it 6 times. So that's 3 minutes. And he's done that 6 times. So 6 lots of 3 minutes. So let's do that, shall we? So that's 1 lot, 2 lots, 3 lots, 4 lots, 5 lots, and 6 lots. Now I'm just going to label them all in 3-minute intervals here. So how many minutes in total? If you can count in threes, fantastic. There's a song that goes 3, 6, 9, 12, 15, 18, 21, 24, 27, counting up to 30. And you could use that to help you count in threes if you really want to. 3, 6, 9, 12, 15, 18. All right, that's 18. So 3 lots of 6 is the same as 6 lots of 3s. And that gives us 18. But 18 what? 18 minutes. So the answer is 18 minutes. You could write it next to here. 18 minutes. All right. Well done. Hope you found that helpful. If you're finding it a bit tricky, getting stuck in it, don't worry. You just got to keep going for it. Okay. Check out all the other videos on how to do the different adding, subtracting, multiplication. I know there's a lot there, and I went really happy with that. I just love maths. I think that, yeah, whatever I'm trying to say, I don't know. Have a lovely time, people. Enjoy this. Hope you enjoy the rest of the Explorers pack. Okay, bye now.